Yes, same to the guy. In this video, we're going to talk about the summary of the structures from the first antimalarials up to the new antimalarials. The modification which were made from the first antimalarials. Please don't forget to subscribe, like the videos, and share. Let's go. Yes, remember the first antimalarials we have quinine. Quinine. This is the structure of the quinine. We have a methoxy here. We have this. This is quinine. And here we have stereochemistry, where here it is R, here it is S. We have other stereochemistries. For example, here we have here S and R, but mainly we are going to focus on these. This is quinine. Then we have quinidine. Same like quinine. Here the changes between quinine and quinidine, they are here. For quinidine, here it is S, here it is R. But these ones remain. This is S and this is R. This is quinidine. We are going to see how they were modified to make other antimalarials. Then there is a synthetic antimalaria which is quinacrine. After identifying that the quinine and quinidine had antimalarial activity, they tried to synthesize other antimalarials. They came up with the quinacrine. Here there is a methoxy group like for quinine and quinidine. Then here this position is this position here is a chlorine atom. Here so this is quinacrine. You can see that here it is the same structure like that of quinine and quinidine. Here this part. You can see. Now, after a decrease in the supply of these quinine and quinidine, remember these were from the quinquina, later named cinchona, back. So from the back of these three, they got these alkaloids and had antimalarial activity. Then later they synthesized this one, but this one had low antimalarial activity. So they had to synthesize other drugs which had better antimalarial activity. So the problem, there was a decrease in supply of these antimalarials from the cinchona bark. Also, the low antimalarial activity of the quinacrine, the low antimalarial activity. So you can see now they had to synthesize other antimalarials. One, they produced quinine. I mean chloroquine, and this is a 4 substituted quinoline. So when you look at the structure of the chloroquine, it resembles quinacrine. It is the right part of this structure. Let's see. It's like this. There's N. Then here there is N with H. This is the methyl group. So you can see that chloroquine is from quinine. I mean the chloroquine is from quinacrine. This part here. This part. All this part is the chloroquine. And this one had better antimalarial activity. Later, they produced hydroxychloroquine. Here is NH. Now, make it black. Substitution of the hydroxychloroquine. This hydroxyl group decreased the toxicity. Of this chloroquine. So you can see from quinacrine, chloroquine, then hydroxychloroquine. Now we have other drugs like mefloquine. They are from quinine. Let's see the structure. Here we have OH. Then here we have CH3, and also here, I see CF. So you can see here, you can see that here they took all this part with a N. I think all this part they produced mefloquine. This is, and we are going to see that metabolism of the quinine. Here there is hydroxylation here in the metabolism, and that one reduces the potency, the concentration of the drug in the body. So substitution of this group stabilizes the drug, reduces the metabolism. We are going to see. Now this is mefloquine. We have other drugs like the harfantrin. Harfantrin also they took the same structure. Then here we have this with OH, but for it there is no N here. There is no nitrogen. And instead of two carbon atoms to the nitrogen, here there is 1, 2, 3. Then here we have two butanes. Then what they added here, remember here, let's make this one also in red. So here they added chlorine, also here a chlorine. Here we see F3 at this position. This is harfantrin. We are going to look at the SARs of these drugs in the next videos. Another drug is romifantrin. Romifantrin. When you look at the romifantrin, it also has this group here. So this ring, the quinoline ring, was made into this ring. Now here, added another ring like this. Then here, with a chlorine. Now up here, we have same groups. We have OH, and here we have a nitrogen and butane. So the groups in red are the groups which were added, or the modifications. Also here we have a chlorine. That is romifantrin. Now other drugs, we have the 8 substituted. 80 substituted quinolines. These drugs we have gotten from the quinine and quinidine also. And they took this part, this downer part, to make these, but this one here. Then for these ones, they made these ones. As we're going to see, we have, for example, permaquine. In permaquine, you have this structure. Use black. And here we have a methoxy group, like that in quinine and quinidine. Then here, at 8th position, we substituted this. This is permaquine. You can see it is from quinine and quinidine. The group in red was the one which was substituted. Then you can see that this structure here at the 8th position is the same like this for quinine at the 4th position. This is 1, 2, no, this is 1, 2, 3, 4, 5, 6, 7, 8. Here, 1, 2, 3, 4, 5, 6, 7, 8. But same structure like the chloroquine. Now for primaquine, after identifying that permaquine was more toxic, they produced primaquine. Here, there is N with H. Now, these groups, the ethyl groups, were removed and were substituted with hydrogen atoms. That one reduced the toxicity. This one reduced the toxicity also. From permaquine, they produced primaquine. We have other drugs like tafenoquine. It's also 80 substituted. I think I should draw it here above. Yes, for tafenoquine, from primaquine, they synthesized tafenoquine. So you have this N, H, H2. So still there is reduced toxicity. Here we have H2 instead of these methyl, the ethyl groups. Here there is a methyl. Now, remember this position here. We say that metabolism occurs here for quinine. Now they were substituted with methoxy group. And also here, they added another group. Here, this is an oxygen atom, then benzene ring and trifluoromethane. I say that is the phenaquine. Pheno queen. So this drug means that here they increase the potency of this drug. It is more lipophilic than this one. And also this one increase the potency and reduce the metabolism. Reduce the metabolism. So you can see now, let's go just shortly for SAR, some SAR just here. You can see that this drug, this one increase the potency due to increase the lipophilicity. And also here, the butyl groups, they increase the potency due to increase the lipophilicity. Also, this group here increase the potency. Same like this group is more lipophilic than this cause of these groups. So we are going to talk about each drug separately, and each group or each class, the 8 substituted, the 4 substituted, then we talk about each drug separately. The metabolism, the resistance, how to overcome them. Then we go to the new antimalarials, those are the artemisins. These drugs, we are going to talk about them and other drugs. Drugs like amodiaquine, but there's no way I can draw it, but I can use this one. This one. For amodiaquine, these are 4 substituted. So 4 substituted, like this chloroquine. But here, they cyclized this part. They made it to be a benzene ring with OH here. This is amodiaquine. This is amodiaquine. And we shall see the effects of adding this group when we talk about amodiaquine and the modifications. For this video, allow me to stop here. Please don't forget to subscribe, like the videos, and share. It's MK the guy. Thanks so much.